Your consciousness is not in your brain. What if just about everything you've been told about your own mind is wrong? From day one, we learn that our consciousness, the very essence of you, lives inside the 3 pounds of wetware between our ears. That every thought, every feeling, every memory is just the result of neurons firing. But what if that's not the whole story? What if your brain doesn't create your consciousness at all, but is actually more of a receiver? This isn't just a late-night philosophical question. It's a journey to the very edge of our understanding, where baffling medical cases and the weirdness of quantum physics collide. Today, we're exploring some mind-bending evidence and speculative theories that challenge the idea that your brain is the source of consciousness. What you're about to hear might just change how you think about who or what you really are. Section 1. The official story and its cracks. For centuries, the dominant scientific view, and the one that still holds today, is that consciousness is born from the brain's staggering complexity. The mainstream model suggests our subjective awareness emerges from a network of nearly 100 billion neurons firing together. It's a tidy, materialist explanation. The brain is the machine, and consciousness is what it feels like when it's running. So if you damage the hardware, you should damage the software in a predictable way. And a lot of evidence backs this up. We know brain injuries can radically alter personality. We can stimulate parts of the brain to trigger vivid memories, and tragic diseases like Alzheimer's seem to erase the self as they degrade the brain. It all points to a pretty clear conclusion: no brain, no consciousness. But that neat story is showing some cracks. It's being challenged by anomalies from 2 very different worlds: the ghostly realm of quantum physics and the shocking realities found in certain medical case files. While mainstream science is still firmly rooted in the brain as creator model, these paradoxes are so strange they force us to ask a radical question. Is the brain really the creator, or could it be something more like a conduit? Section 2. The first crack: quantum strangeness. Our first stop is the utterly bizarre world of quantum mechanics. Down at the smallest scales of reality, the rules we know just break. And at the heart of all this weirdness is the observer effect. The most famous example is the double-slit experiment. When scientists fire tiny particles, like electrons, at a barrier with 2 slits, something wild happens. If no one is watching which slit the particles go through, they act like waves, passing through both slits at once and creating a distinct interference pattern. But, and this is the kicker, the very moment a detector is placed at the slits to observe which path a particle takes, its behavior instantly changes. It stops acting like a wave and acts like a single, solid particle, and the wave pattern vanishes. It's as if the act of measurement itself forces a particle to snap from a haze of possibilities into a single reality. Now, to be clear, mainstream physics doesn't suggest this requires a human mind. Any interaction with a measuring device will do the trick. Still, the philosophical implications are huge and have led some thinkers to wonder about the connection between consciousness and reality. It begs a profound question. If observation is baked into the fundamental nature of the universe, what does that say about the consciousness doing the observing? Is it just a glitch in a biological machine, or something far more fundamental? This quantum enigma is the first hairline crack in the conventional story. Section 3. The second crack: the phantom brain cases. If quantum physics offers a philosophical crack, some rare medical cases blast a hole right through the wall. These are stories that, according to our standard understanding of the brain, just shouldn't be possible. Take the case of a 44-year-old French man who went to a doctor for mild leg weakness. He was a married father of two, held a job as a civil servant, and lived a totally normal life. When doctors did a brain scan, they were stunned. His skull wasn't filled with a brain. It was almost entirely filled with fluid. A condition he'd had since childhood had slowly squeezed his brain tissue until all that was left was a thin layer pressed against the skull. He was missing an estimated 90% of his brain. And yet, he was there. He was conscious. He was a functioning person with an IQ of 84, a bit below average but not severely impaired. How is that possible? If consciousness is a product of the whole brain's computational power, how can it survive when the computer is mostly gone? Mainstream neuroscience points to the brain's incredible ability to adapt, a concept known as plasticity, to explain these rare cases. But you have to admit, it still makes you wonder. This isn't a one-off. There are documented cases of children born with hydranencephaly, where the brain's cerebral hemispheres are almost completely absent, who still show basic responses like smiling or crying. While neuroscientists often interpret these as reflexive subcortical responses rather than proof of true consciousness, these phantom brain cases present a fascinating challenge. They push us to question if the sheer volume of brain matter is the only thing that matters. Section 4. The new theory. The brain as a receiver. So what if we've been looking at it all wrong? What if the brain doesn't generate consciousness? This is where a speculative, fringe idea known as the receiver hypothesis comes in. To be clear, this is not a mainstream scientific theory. The vast majority of neuroscientists remain focused on the brain's internal networks as the source of consciousness. But this alternative idea is so elegant in how it explains the weirdness we've just discussed. Picture consciousness as a fundamental field that exists everywhere, like gravity. In this model, the brain isn't a factory making a product. It's more like a TV, tuning into a signal that's already being broadcast. Your brain, with its unique structure, acts as a complex filter, localizing that universal signal into the personal stream of awareness you call you. Your thoughts and memories aren't created by your neurons. They're the result of how your specific brain tunes and modulates the signal. This model offers a neat explanation for the French man. His receiver was badly damaged, but it wasn't off. It could still tune into the signal, just with less processing power, resulting in a lower IQ but a preserved self. The broadcast was fine. The hardware was just compromised. It also aligns philosophically with the quantum questions. If consciousness is a fundamental field, it makes more sense that it could be linked to the fabric of reality itself. Highly controversial theories, like the OR model from Roger Penrose and Stuart Hameroff, even propose our brains are essentially quantum computers, tapping into the universe's basic structure. While these ideas lack empirical support and are not widely accepted, they show that some scientists are willing to think way outside the box. Conclusion. The implications of this perspective are staggering. If your consciousness isn't generated by your brain, then who are you? It suggests that you might be more than a fragile biological machine, that the brain is the instrument, but you are the music. And the music doesn't necessarily stop just because the instrument gets damaged. This view reframes everything, suggesting our consciousness is far more interconnected than we've been led to believe. It opens the door to seeing things like intuition or sudden creative insight not as brain glitches, but as moments when our receiver tunes into a clearer signal. We are nowhere near the end of this investigation. We're at the beginning of a huge scientific and philosophical revolution. The evidence doesn't give us all the answers, but it sure makes us ask bigger, better questions. If this little trip to the edge has you thinking, make sure to subscribe for more deep dives into what we know and what we don't. Now I want to hear from you. What's your take on all this? Is the brain a generator or a receiver? Let me know your thoughts in the comments.